All right, now we're going to look at right triangle applications and what that means, a few word problems. And we're going to use everything we've learned about right triangles in this chapter to do that. Every triangle, you have 3 sides and 3 angles. And if you know 3 of the 6 parts, then you can find the other 3 parts by using the different trigonometric ratios. And when the book says to solve the triangle, they want you to, find all 6 parts. So they have a little strategy here on how you do this. Number 1, it says if 2 angles are known, then the third angle can be found by using the property that the sum of the 3 angles is 180 degrees. If 2 of the sides are known, then you can use the Pythagorean theorem to find the other side. If you have one side and one of the acute angles are known, you can find the other by using trigonometric ratio. It says if neither of the acute angles, and the acute angles are the angles less than 90 degrees. If neither of the acute angles is known but 2 sides are known, both acute angles can be found by using trigonometric ratios. And they say when doing this, you should always try to use the values that are given to you and not the values that you have found, because you can make an error, and if you base all your answers on some calculation you found, then you may end up getting the whole problem wrong. Let's look at a couple of examples. In problems, the next couple of problems that we're going to do, excuse me, they want us to solve the triangles with the given parts. Okay, so the angles are the letters, and the angles are the uppercase letters, and the sides are the lowercase letters. Okay, so essentially, angle A, angle B, angle C. They give us angle A being 45 degrees. They give us side B being 16.0 degrees. Now, it's not stated here, but this is a right triangle, so we know angle C is 90 degrees. So we can definitely find B. Remember that the sum of the angles is 180 degrees. So you have 180 minus 90 minus 45. B is 45 degrees as well, which we already knew this from the last section, that you have a 45, 45, 90 degree angle, triangle. So we know side B. We need to find side C and side A. Well, let's talk about how to do that. Side B was 16, and we were given this at 45 here. So if I look at this and I want to find A, I have opposite over adjacent. So A is going to be, or excuse me, let me rephrase that. We have the ratio of opposite over adjacent, and tangent of our 45 degree angle that we knew equal the opposite, which is A, over the adjacent, which is 16. So what this means is that 16 times tangent 45 degrees equals A. And if we put that in our calculator, we should get that A is 16. If you want to find C, again, to find C, we're given B, we're given A, so we have adjacent over hypotenuse. So remember that cosine of this A, which is 45 degrees, equals the adjacent side over the hypotenuse. So that C is, if you multiply both sides by C and divide both sides by cosine 45 degrees, C is going to be 16 divided by cosine 45 degrees, which is 22.6. 22.6. Let's look at number 10. We have this triangle. In number 10, we know this is 90 degrees, right triangle. We have angle A, angle B, angle C. And here we are given that little a is 734 and little b is 129. Okay? Now, we can find definitely little c by the Pythagorean theorem. Okay? C is going to be the square root of 734 squared plus 129 squared. So C is 745.2. And we need to find our angles, but we want to use the A and the B. If I look at angle A in relationship to what I'm given originally, I have opposite over adjacent. So that's tangent. Tangent A is opposite over adjacent. So remember, you got to do the inverse tangent to get what this angle is. So A is going to be 80.0 degrees. And to get B, this is the angle B, you have, again, opposite over adjacent. So tangent B, the opposite side is 129. The adjacent side is 734. So B is going to be inverse tangent of 129 over 734, and that's 10.0 degrees. Okay, we have a couple more problems. Same instructions. Right triangle. A, B, C. We're given that the angle B is 84.5 degrees. The side C is 17.30. Okay. So if we look at this angle, we're given the hypotenuse. If we want to find side B or side A, to find side B, we have opposite over hypotenuse, and that's sine. So sine of 84.5 is the opposite side, which is B, over the hypotenuse, 17.30. So if I multiply both sides by 17, oh, that's not 17.3, that's 1730. 1730, large number there. So 1730 times sine of 84.5 gives us B. So B is 1722.0. And in relation to B, if we want to find little c, that's adjacent over hypotenuse. So that's cosine. So cosine of 84.5 equals adjacent, which is A, of the hypotenuse, 1730. So if I solve for A, I get 165.8. So we have our A, our B. We now need to find angle A. And we knew angle C. Angle C, of course, is 90 degrees. So angle A is going to be 180 minus 90 minus 84.5, which is 5.5 degrees. That's our angle A. Remember, in the right triangle, angle C is always given. It's the 90-degree angle, if it's labeled that way. Generally, you do label the right triangle C. So in this next problem, they're giving us the hypotenuse, (7.14), and they're giving us B, 1.89. We can definitely find A. A is the square root of the hypotenuse squared minus the other leg squared. So A is 6.89. And now let's try to find these angles. Notice we're given the hypotenuse and the one of the legs. So if I think about finding my angle A, we know the big C, of course, is 90 degrees. If I think about finding my angle A is going to be what? I'm given the adjacent hypotenuse, so cosine A is the adjacent of the hypotenuse. So A is the inverse cosine of that, and you get 74.7 degrees. To find my B, I'm given opposite over hypotenuse, so sine B is opposite, 1.89, over hypotenuse of 7.14. So B is the inverse sine of that, which is 15.3 degrees. Don't leave your degree symbol off. All right, a couple of more problems. Here we have the actual word problems, application problems. And we have to draw a sketch in dealing with these type problems as well. Number 18 says the angle of elevation of the sun is 51.3 degrees at the time a tree casts a shadow of 23.7 meters long. So we have a tree. It casts a shadow, 23.7. The angle of elevation here is 51.3. They want us to find the height of the tree. They want us to find the height of the tree. So we're given this angle. We want to find the opposite. We're given the what? Adjacent. Remember that tangent is opposite over adjacent. So X is going to be 2.3 or 23.7, I'm sorry, times tangent, 51.3 degrees. So X is going to be 29.6 meters. 29.6 meters. All right, our next problem, number 20, says a guy wire whose grounded end is 16 feet from the pole it supports. So you have a pole it supports. makes an angle of 56 degrees with the ground. So this guy wire is going to be our hypotenuse. It makes an angle of 56 degrees with the ground. It's grounded in is 16 feet from the pole. They want us to figure out how long the wire is. We need to figure out the hypotenuse. So we have adjacent over hypotenuse, which is cosine. Cosine 56 degrees is the adjacent side, which is 16, over the hypotenuse, which is x. So x is 16 divided by cosine 56 degrees. So x is going to be 28.6, and our unit here is feet. All right, the next one, number 24. A roof raider is 5.25 meters long, neglecting the overhang, and its upper end is 1.70 meters above the lower end. Find the angle between the rafter and the horizontal. So a roof rafter makes a slant, 5.2 meters long. Its upper end is this, the distance between here and there, a vertical distance, is 1.7. They want to know between the difference or the angle between the rafter and the horizontal. So here we have opposite over hypotenuse. So sine x is opposite over hypotenuse. So x is going to be the inverse sine of that stuff, which is 18.9 degrees.